Hi, welcome to EC&M Tech Talks. This is a series of how-to videos where we cover everything from basic theory and the equipment that we install and maintain out in the field to some of the codes and standards that apply to the installation and maintenance of that equipment as well. So this Tech Talk video is brought to you by EC&M Magazine. That's EC&M Magazine. You can find them at ecmweb.com. You want to go there. You want to go to ecmweb.com. And if you take a look when you get to the home page, look up in the upper left-hand corner and you'll see a drop-down menu. And what you want to do is you want to go to the premium content. It's the very first item on the drop-down menu. You want to go to that premium content page and sign up as a members only for premium content. So Electrical Construction and Maintenance Magazine, ecmweb.com, is where you want to go to sign up for that. And what the advantage of that? Well, one, it's free. When you view videos like this, you're going to find lots of information related to the topic that we're talking about in that particular video. So lots of free, good resources for you. Lots of pretty color pictures, I always say, which helps me to understand things. And of course, our videos as well. So I'm Randy Barnett, and I'll be your host, facilitator for this EC&M Tech Talk, where today we're going to be talking about flexible cords and cables. All righty. You might say, oh, Article 400 of the National Electrical Code, or you might say, oh, cords and cables. You mean like, oh boy, we're going to get into medium voltage cables and type MC, metal clad cable, and all of those type things. And no, we're paying just particular attention today to Article 400 of the National Electrical Code on flexible cords and cables. So we're going to figure out what all of that is. We're going to see that actually the National Electrical Code does a great job of explaining to us what all of these flexible cords and cables are, typical applications, where we can use them, where we can't use them. Oh gosh, we've got to do ampacity calculations, don't we? And figure out what ampacity's values are based on the conditions of use and all of that. So that's what we're going to be taking a look at some of that today, as well as we'll pull some of those cables down. We'll take a close-up view of how they're constructed on the inside and the ratings and markings on them and so forth. So anyway, the OSHA, Occupational Safety and Health Administration, is where we're going to find our OSHA regulations for flexible cords and cables. And actually the way it works is if you take a look at OSHA 1910, which and then subpart S, and subpart S is where we find our electrical rules for general industry then. And section 305, okay, so 1910, 305, subsection G, right? So 1910.305G is where we find our rules in OSHA for flexible cords and cables. Now, how important is that? Well, I don't know, I remember a few years ago, they had, I think OSHA said they cited Article 400, or flexible cords and cables, in other words. They cited about 2,500 violations, and that resulted in almost $3 million in penalties. So, oh, okay, maybe I should take time to make sure I meet the OSHA requirements. Well, if I go to 1910.305G, what I'm going to find is, well, gosh, that's sort of like just like in the National Electrical Code, isn't it? And the answer is yes. Okay, so we're going to end up in Article 400, as I say, on flexible cords and cable. As always, I'm using the most current National Electrical Code, and right now that is the 2020 NEC. So we'll be into the 2020 NEC then. And one of the first things that I want to call your attention to in the 2020 edition is, what the heck are all these flexible cords and cables? I mean, it just says, in the first section there on the scope, it says it applies to flexible cords and cables 400.1, and then there aren't really any definitions for flexible cords and cables, but I can find them all. Table 400.4. So let's take a look at table 400.4, and it's a very long table. It's about 6 pages long, so we're not going to look at all that. I just want to show you the headings, because after we look at the headings and see what kind of information is available to us in table 400.4, we're going to pull down some of those cords and cables, and we're going to take a look at them and see if some of this stuff starts to make sense to us then. So let's take a look at 400.4 then. And table 400.4, flexible cords and cables from the NEC. And don't worry about trying to read all of this, because as I say, it's a table about 6 pages long, very small print. I'm going to, as I go through the cables behind us and cords, I'll explain all the information to you. But I want to show you the type of information that's available. For instance, there's trade name. And the trade name for the first one, for example, just it says it's lamp cord. Okay, lamp cord. You got plenty of lamp cord around the house probably. The type letter is type C. It's available in voltage ratings, it tells us, of either 300 or up to 600 volts. It gives us different gauge size it's available in. For instance, lamp cord, it looks like, is available in gauge sizes 18 up to 16 and from 15 to 10 AWG. And that 15 may have caught you a little off guard, huh? The number of conductors, it says there's 2 or more conductors in a lamp cord. The type of insulation around the conductor itself, not the outer jacket, but the conductor around the insulation around the conductor itself is a thermoset or thermoplastic. And for instance, it says in 18 up to 16 gauge that insulation thickness is 0.76 millimeters or 30 mils, 30 thousandths of an inch thin. Right? Now, usually we don't get down to that level and have to worry about that too much, do we? Is there a braid on each conductor? It says yes, there's cotton. Is there an outer covering? None on lamp cord. And we're going to take a look at some that we use out in the field most commonly, and we definitely find an outer covering or outer jacket. And it's suitable for pendant or portable use in dry locations and not hard usage. So we're going to talk about all of those terms as we go through. So let's pull down some of these and we'll take a close-up look at them and see how they're constructed. And then we'll talk about the remainder of the information that we find in Article 400 that commonly applies to us out in the field then. So this is the first flexible cord that we'll take a look at. The first thing we might notice is on the outer jacket, there are some markings. Those are required to be there by the code, and it tells us specifically what those markings must be. And it tells us they have to be there every 24 inches. Now, that's a little hard for you to read. So I'll read what I can on the flexible cable back here on the outer jacket. It gives me the manufacturer's name, and then it says cord, 3 conductor 6 AWG. So 3 conductor cord, you have to be careful now when you specify this cord. We're not talking about just the current carrying conductors. We're talking about the total number of conductors in the cord. Now this is 6 AWG. So we might see it, abbreviated 6/3C, something like that. 6 AWG, 3 conductor. So there are 3 conductors. We have our ungrounded conductor with the black insulation. We have the white insulation on this conductor, and then we have the green for the equipment grounding conductor. Now, when it comes to calculating my ampacity values, what you have to remember is you've only got 2 conductors that are current carrying, right? So that's going to place you into the proper column on the table for ampacity values. So you got to remember that, how many are current carrying and how many are total conductors inside of the flexible cable. Now, if we were to go to table 400.4, if you remember, it's the one that provided us all the information on the different types of cables. So if I continue reading on the outer jacket, it says, well, 3 conductor, 6 AWG, then it says SOOW, 600 volts. So when I look in table 400.4 on my properties for my flexible cords and cables, for SOOW, the first thing it tells me is that this is a hard service cord, which means that it has the S. Okay, so if it has the S, SOOW, the S indicates that it is rated, the insulation itself is rated for 600 volts. If it was a junior hard service cord, SJ, then the insulation itself would be rated for 300 volts. The SOOW, so the S tells me that the insulation is rated for 600 volts. The first O tells me that the outer jacket is oil resistant. In fact, the table tells me it's an oil resistant thermoset. The second O tells me that the insulation itself is an oil resistant thermoset. It also tells me in the table that this particular SOOW type cord is available in gauge sizes, 18 up to 2 gauge. It may have 2 or more conductors inside the flexible cable. It is a thermoset type of insulation over the conductor material. Keeps it very flexible, by the way, as opposed to a thermoplastic we'll look at in a minute. And then it gives me the dimensions for the different gauge sizes. It gives me the thickness of the insulation. And it says the braid on each conductor. No, there's not braid on each conductor. There is some paper on the inside here. You can see it's intertwined actually before I unwound it, but it's intertwined around the outside of the conductors. And just for kicks, I said, well, that's just a regular old brown paper. So I took and I dipped it in some water, cut off a piece of it and dipped it in some water. And boy, it wicks water pretty quickly. And then finally, it gives me my usage, typical applications for this. And it says it's good for pendant or portable usage. It's good in damp locations with just the SO, but that W suffix on the end, that tells me it's suitable for damp and wet locations. So of course, that's very important to me then. So that's an example. That's probably most commonly used. Quite often we might say, well, I'm going to run to the shop and get some SO cord. It's probably not really SO, it's probably SOOW. Here's a typical cord. It is SJT. So SJT tells me that it's rated, the SJ tells me that it's rated, the insulation, for 300 volts, and the T tells me it's a thermoplastic insulation. So this is a thermoplastic just like we'd find on our typical building wire then. One of the most important things probably on this cord set is it does have the UL label on it. You'll find on the outer jacket, it's going to say SJTW. So it is SJ, which it is. It tells us on here it's rated for 300 volts. It has T, a thermoplastic type insulation over the conductors on the inside, and W, this one is suitable for a wet location then. So that is our flexible cords and flexible cables. Taking a look at them. Let's head back to the National Electrical Code now. All right, we've got them hung back up. So let's go back to the NEC, back to 400.5, which is on ampacity values. And it's going to tell us how to calculate these ampacity values on these different types of flexible cords that we've been taking a look at. So there's a table, okay, that's going to help us a lot. It's table 400.5A1 that covers a whole bunch of the different types of flexible cords and cables we just looked at. There's also another ampacity table, 400.5A2, for some very specific type flexible cords and cables, such as SC, portable power cords, type W, GGC type portable power cable. A lot of these are rated up to 2000 volts. We might find them typically the GGC and mining applications and so forth. So anyway, but we're going to take a look at table 400.5A1 is what we want to talk about, and ampacity values. Now, when it comes to flexible cords and cables, it's just like any other ampacity value. Ampacity, what's the maximum amount of current that a conductor can carry under its conditions of use without exceeding the temperature rating of the insulation on that conductor then. 400.5A is based on an ambient temperature. It says 86 degrees Fahrenheit, which is 30 degrees C. Okay. And we're going, as the ambient temperature changes, we know that the resistance of the copper conductor changes. And so therefore we have to make corrections for different ambient temperatures. Now, what's interesting about Article 400 is it says that, hey, if you need to correct for ambient temperature, it's copper, it has a certain type of insulation on it, you have to go back to Article 310. And 310.15B1, ambient temperature correction factors based on 30 degrees C, 86 Fahrenheit. So I have to go all the way back to Article 310 then to start to correct for ambient temperature in a flexible cord. Now, also, what if I have more than maybe 2 or 3 conductors or whatever? Well, I also have to do adjustments for the number of conductors inside of my flexible cord. And there is another table for that. That is back in Article 400. Article 400, table 400.5A3 is adjustment factors for more than 3 current carrying conductors in a flexible cord or flexible cable. And so there it's very similar to what we do when we run more than 3 current carrying conductors in a raceway. We take the number of conductors, we look at the table. For instance, if I have 4 to 6 conductors in my flexible cord, percent value of the ampacity value that I have to take is 80%. So I would have to, if my ampacity value on the table was 10 amps, but I had 5 conductors for some reason in that flexible cord, I would have to take that 10 amps and multiply it times 80%, which would give me what? 8 amps. So now my new ampacity value, based on the number of conductors in the flexible cable, would be 8 amps instead of 10 amps. And then, of course, I still have to correct for the ambient temperature. So that's how I do my ampacity on my flexible cords and cables. If we look at that table on the ampacity values, 400.5 A1, it lists 2 different columns for each type of flexible cord or cable. And the first column is if I have 3 conductors, it gives me the ampacity. And then the second column is when I have 2 conductors that are current carrying then. So you have to pay attention to that. So anyway, fairly simple table to use. Always read your notes at the bottom of the table. And remember that you must adjust for the number of conductors in the flexible cord or flexible cable. And you must also correct for ambient temperature. Other items of importance, as we would expect in sections .10 and .12. So 400.10 is uses permitted, and 400.12 is uses not permitted. So for example, 400.10, where can we use flexible cords and cables? Probably a lot of places we're already using them, right? Pendants, wiring of luminaires, connection of portable luminaires, elevator cables. In fact, there is in the table of 400.4 specific information on elevator cables, wiring of cranes and hoists, prevention of the transmission of noise or vibration. Oh, we use flexible cords and cables sometimes on motor applications, don't we, as well? Connection of moving parts would make sense. We're specifically permitted elsewhere in the code. For example, there are applications in hazardous locations back in Chapter 5, where we can use certain types of flexible cords, flexible cables, and of certain types in given applications and so on. Use is not permitted, as we find, is in .12. And so use is not permitted in .12. Substitute for the fixed wiring of the building. No, I can't use flexible cord for that. We're run through holes in walls and structural ceilings, things we never see out in the field, right? Above suspended ceilings, drop ceilings or floors. Oh, never run into any of that. We're run through doorways, windows, or similar openings. We're attached to building surfaces, and there are exceptions for that. But anyway, bottom line is our flexible cords and cables, pay particular attention to them. There are a lot of misapplications of them, I feel like, out in the field. There's a reason, as we've seen in the construction, a very definite reason that the way these flexible cords and cables are put together. And so we need to apply them properly. Follow their ampacity ratings and make your corrections and adjustments as needed, and follow that table 400.4 to make sure that you're choosing the right cord for the right application then. So we're about out of time for the day. I encourage you to go back to Article 400 and review it. It's still a few more pages of information there for you, talking about splices and attachment plugs, and it does get into flexible cords and cables over 1,000 volts. But anyway, pay particular attention to your flexible cords and cables. Make sure that you work safely. You apply these rules correctly out in the field. And we'll see you on the next EC&M Tech Talk.